So today I'm going to take some notes with you on stoichiometry practice and limiting reactants. Here is the first problem from stoichiometry practice number 1, and we're going to work through this problem as we take stoichiometry notes. So just so we understand what's being required of us, it says for each of the following problems we need to make sure that we balance the equation, then using the given amount of each reactant, determine the number of moles of the chemical that reacts, the moles of any extra and what they are, and the moles of each of the products produced. And finally, identify the limiting reactant. To start off, I want to explain what this thing called the limiting reactant is. We have a reaction here as this example showing hydrogen gas and oxygen gas producing water. Okay? And I've given you a scenario of how much I provided for you. I've given you 5 moles of hydrogen gas and 2.3 moles of oxygen. So I'm going to give you an analogy now to explain what limiting reactant is. When we purchase, let's say we're having a birthday party and we purchase hot dogs and hot dog buns. And when we purchase the hot dogs and hot dog buns, the hot dogs come in packages of 8, while our hot dog buns come in packages of 6. So if we were at this birthday party and the only combinations we could make is with the bun and the hot dog, we are limited by the number of hot dog buns to hot dog combinations because of the number of hot dog buns. We only have 6 and we have 2 extra of the hot dogs. So our limiting reactant, I guess you can say, as a reactant would be, is the hot dog buns in this case for the analogy. So the same thing happens in chemistry. We are given a scenario. However, we need to first figure out which of the reactants are limiting to produce the product. In this case, we have a synthesis reaction, so we have 2 reactants and we have 1 product. If we were to have more than 1 product, we could individually be able to identify how much or how many moles of each of the products we have. So the first thing in the stoichiometry notes I want you to do is make sure that we can write down our equation properly. Okay, so I've already started that off by writing the formula from the longhand. I'll show you what the longhand is again. The next thing you must do in order for this equation and to be able to solve it is to balance the equation. And the reason why this is so important, so our next step is to be able to balance the equation. So I'll balance it here on this paper. We have a 2 giving us 4 hydrogen. We'll put a 2 on the water, give us 4 hydrogen here, 2 oxygen and 2 oxygen on our reaction side. It's a reactant product. The third step is to write down what is provided. So I'm going to just write down right here, provided, and we actually are given the number of moles provided. So I'll be very specific there. And this is how much we were provided. So one thing we do need to start off with in stoichiometry, as you notice, is we do need to start off with the number of moles, because what we'll be doing is we'll be taking the number of moles and comparing it with a mole-to-mole ratio. And I'll show you how to do that in just a second. So our lesson from last week of how we convert grams to moles, and actually moles to grams back and forth, just the conversion with the setting up the proportion is critical that you know how to do this. So you're going to convert as your next step. It says convert to moles if it's not in moles. Well, it is in moles. I started it off in moles for our first lesson, so there's nothing else you need to do. It's already been converted for you. I've balanced the equation out on paper as well. I've also written it out in case you need to remind yourself of what it would look like if it was completely written in longhand. And then we'll do the next steps. And then for the next steps, I'm going to work on the actual worksheet that we had given you, so that way we're going along with this worksheet. So these are the moles that are provided. You want to then set up a mole-to-mole ratio to compare to figure out which one of these are the limiting reactant. And what we're going to learn now is a new vocabulary. These values, and if there's no value here, remember that that is a number 1 that we do not need to write. The values called the coefficient, this is what we termed them last unit, is actually the number of moles of that molecule. So we have 2 moles of hydrogen gas with 1 mole of oxygen gas yields 2 moles of water. So now we're going to set up the mole-to-mole ratio to determine our limiting reactant. I want to set up the known portion first. We have 1 mole of oxygen to 2 moles of hydrogen. And this comes directly from our coefficient. Okay, so I will put this from the balanced equation. We can figure out the limiting reactant. So I'm going to shorthand now LR as limiting reactants. So I'm going to show the setup of just how to find the limiting reactant. Well, there's 2 reactants, so I'm going to have to compare them. 2 moles of hydrogen. First one is I'm going to set up, either way it doesn't make a difference, I'm going to take my provided, and this is my moles of hydrogen. So I want to make sure that my denominator is the same, so I'll take my 5 moles of hydrogen of what's provided, and then I'm looking for my moles of oxygen. Remember from last week that we learned when we set up the proportions, the units have to be the same. Then I'll set up the next proportion, and we are given 2.3 moles of oxygen, and we're looking for moles of hydrogen. And again, this is just to determine the limiting reactant. So first, you take the moles from the balanced equation, you have the mole-to-mole ratio, and then you have the moles of the given, which is provided. That means Mrs. Sulkson provided you values, so you're solving it. And here you have your 2 numbers. You cross multiply, 1 times 5, and you divide by the other, which is divide by 2, and you get 2.5 moles of oxygen. Here you have 2.3 moles times 2 divided by 1, and you get 4.6 moles of hydrogen. So the next step is to determine which one is actually the limiting reactant. So you need to compare what is provided to what you actually have solved. And in here we have 2.5 moles of oxygen. This is more, so we have more available than what is provided. Here we have 4.6 moles, so we don't have enough of what's provided. So the one that has the more, so this one is less, the amount that's provided is less than the amount that we have, we then can label this as our limiting reactant. They sometimes refer to reactant as reagent, which is the same thing. So in effect, we have limiting reactant is oxygen. So with this information, this can tell us a lot. First of all, we'll be able to figure out how much excess we have of hydrogen that's still available. So here we have 2.5 available, but we only reacted 2.3. So our next step is to determine, so far we've balanced the equation. We are now figuring out the moles of each chemical that actually reacted. So moles provided, and now moles reacted. So I'll put that over here on the side since I've kind of explained this in a large format. And I'll put over here on the side. So the moles reacted. Okay, we had 4.6 moles reacted of our hydrogen, and of oxygen we had 2.3 moles. And if you're wondering why I did not put 2.5, well, that's how much could have reacted. However, we were only provided 2.3, so 2.3 reacted. So our next question, our portion of the question, says your moles of excess. I'm already going to shorthand MOL for moles. So we can take 5.0 minus 4.6 of what actually reacted, and we get an excess of 0.4 moles of hydrogen is left. While we reacted the entire, so 2.3, we reacted all of our oxygen, and that's why it's the limiting reactant, so we have no excess. So your limiting reactant will be the one that has nothing in excess either. The next part and the last part says give me the moles, or calculate the moles of the product. I'm going to go over here on the side. So now we have our product of water. So we can use our information that we know is our moles of oxygen, the moles of oxygen. So this is the limiting reactant. I'll circle it here as well, so it's very obvious, and I will put limiting reactant. And I will set up the equation, 2.3 moles of oxygen, and we're trying to figure out how many moles of hydrogen are we making. We have it already in moles. Again, remember, stoichiometry, you always start in moles, so you must convert it into moles if it's not in moles. Well, it's already in moles, and then you do the mole to mole ratio, except now you're comparing oxygen to water. When you're doing the limiting reactant, you were comparing hydrogen to oxygen to hydrogen. So whatever you're comparing it to, you can set up the mole to mole ratio. So here we have 1 mole of oxygen to 2 moles of water. Then you cross multiply 2.3 times 2, and you divide by 1. And again, remember, this is from the balanced equation. So when you cross multiply and divide, you have 4.6 moles of H2O, or water, that's produced. Always box in your final answer, because you can see how all this work comes down to the final answer of 4.6 moles. That's not that handy because we still can't measure that out in lab. However, we learned last week that we can take moles and convert it to grams and vice versa by multiplying by molar mass. So you could take this 4.6 moles of water and multiply it by its molar mass and convert it into grams. And then you could get your final answer using how many grams of water that you have. Again, this is if you do not know and you have to figure out which one is limiting. There's no excess of the moles available. Some stoichiometry practice will mention that you have excess of both, and then you would be skipping this middle area of figuring out the limiting reactant, and you could go directly into figuring out how much of the product is produced. Stop and go and review these notes so you can practice the rest of the stoichiometry practice number 1.